Okay. All right. So today we're going to go over um, a bit more about the mechanical model, like stuff that we can do, and then we're going to go into ACP analysis, and if we have time, we'll go into loads and structural analysis. All right. So last thing that we need to do here is we need to, so this is the same panel from last week, but this time there's 4 mounting holes and I split it accordingly to indicate that this is the area around which fixed connections will appear. But for now, we're not going to worry about that. One thing that we need to do is before we can carry out analysis is that we need to split up the model further. So let's say that you have the center of the panel is 3 plies and the sides of the panels are doubly reinforced, so 6 plies. So how do you indicate that there's a difference between the ply count in different areas of the model? That's where name selections come in place. So to create a name selection, all you have to do is, assuming that you already split the geometry up in space claim before, when you go into an ANSYS mechanical model, you should be able to select the different faces. So just remember to click on the face selection tool, and then you should be able to select the different faces. So in this case, yeah, I'm just going to delete what I said before. So let's say I want to create a name selection for the center plate. What I do is first I click on it, right click it. Under the option, it would all the way down, there should be create name selection. Alternatively, you can press Shift N, and that will create a name selection for you as well. Once you've done that, it will come up with this pop-up called selection name. Just rename it to center panel, or like whatever appropriate name you feel like, and say okay. So this can be done for faces. Also, you can do it for edges as well and vertices. The edges and vertexes we will cover why you'd want to do that later. But for now, this is just how you create name selections. This is rather important for later. So once you've created your name selections, you can click on them, and when you click on them, it will highlight the red, like the red geometries that have been selected. After that, you can close out. You're pretty much done with mechanical. So just remember, you have to first declare the surface type, like the material involved, as well as the thickness of the material. You do the mesh, and then create your name selections. Once you've done that, all of it should have a green tick, and then you can exit out. And remember to update the project. Okay. So once you've updated the project, you should see all green ticks. And once you have all green ticks, what you want to do now is go to ACP pre under component systems, and this is where your composite systems come into play. You click and drag ACP pre, and then you drag it over to the model box that you initially earlier settled. So in this case, I'm going to drag it over to this one here. And you'll see that all the lines will connect to the appropriate things. So remember what I said about ANSYS being pretty much a bunch of toolboxes with a flow going on. So all of these data that you created in mechanical model will go into ACP pre. So in this case, you can have 2 different ACP pre for the same mechanical model. And one reason why you want to do this is because you're testing multiple different layups, and it's just easier to have different setups going forward so that you can analyze them differently and see which one works best. I like to do this when I'm trying to cut down on the number of plies I'm using. So I will create like, okay, I know this is the base that I like, but I want to see whether I can further cut down on a few more plies. and then I'll start copying over the mechanical model stuff into different ACP pre's and playing with it there, so that you don't have to like adjust the data that you already created for your base model. It's just nicer that way. So once you've done that, go on to click on, so remember to click update project. And then once you've done that, click on setup under ACP pre. So that's the last box. So once you double click it, it should open up something. Okay, there we go. All right, there we go. All right, so now under ACP pre, things get slightly complicated, but there's more or less a flow going forward. You just have to work your way down the list up until you get to modeling ply. And then once you're done with the modeling ply, you know you're pretty much set. All right, so first thing that we want to do is first, under material data, there's two options called materials. So open up, so it'll all come collapsed. So you want to open it up, make sure that you have epoxy carbon woven there. This is really important for later checking. And once you check that you have the material, appropriate material there, click on fabrics, and usually you should come up with a right option, like create fabric. Once you've created fabric, you should see like fabric 1, fabric 2 pop up. So in this case, I want to rename it like carbon fiber. So just remember to make it that it's a easy to use like name that you remember. Then select epoxy carbon woven. And then under thickness, this is where you consult your data sheet and then look at the thickness per ply. In this case, I know that the carbon fiber sheet that we're using, the thickness is 1.9 millimeters. But for simplicity's sake, I'm going to make it like 2 millimeters. So look at the units that you're using. In this case, we're using MKS, so meters. So I'm going to put it in meters, which is 0.002. And I'm going to press OK. So in this case, I already created a carbon fiber prepreg, so I'm going to delete these guys here. Okay, and then after you've done that, now let's say you have Stackups, all right? So let's see. Okay, so under Stackups, you want to create a Stackup. So remember how I said that we will have, for different pieces of the thing, of the component, you might have less plies here, more plies there. This is where your Stackups come into play. Your Stackups essentially allow you to define, instead of having one ply, you can have like 3-4 plies in one thing. This is just to make it easier for you to apply the carbon fiber plies later. So because otherwise what you have to do is manually insert each ply, and when you're going, for example, the seat, you have to insert 12 plies. That can get rather tedious if you have multiple components. And yeah, so different like layups. So in this case, we're going to do a stack up. So in this case, we're going to do one for the edge stack up, which I am going to reinforce, make it thicker. In this case, I'm going to do 6 plies for the edge, 3 plies for the center. So under symmetry, you want to say even symmetry. Why? This is a composites like material property thing where it just decouples the 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 shear stress from the normal stresses. So the thing with carbon fiber is that if it's not an even symmetry, okay, this is getting complicated, but just do even symmetry. It makes it simple, and it's a lot more predictable in how the material will, in how the structures will deform under certain loadings. Yeah, when you get more advanced, then you can do really cool stuff with the different types of symmetry that you use and tailor it accordingly to the different. So, for example, if you have a wing and you want it to deflect in an opposite direction, or like you want it to twist when there's a loading applied normally to it, so that the angle of attack increases or something like that, you can do it with different material properties, with the different ply stackups. But for now, we're just going to keep things simple. Generally, things like the seat, the steering wheel, all will be done with even symmetry, where we're not talking about any crazy material properties that we want yet, right? But yeah. So if you take advanced mechanical engineering class like MAE 166C, you'll see what I'm talking about and how to achieve these different types of material properties that you want. So in this case, for the edge, I want 6. So in this, I'm going to select carbon fiber prepreg, which was the fabric that we created earlier. I'm going to create another carbon fiber prepreg. 45. And then another carbon fiber prepreg. 0. So because this is an even symmetry, and I'm doing 6 plies, I need to do 3. So what happens is that ANSYS will mirror it automatically around this line. So for example, after carbon fiber prepreg, what automatically gets populated will be carbon fiber prepreg 0 degrees, carbon fiber 45, carbon fiber 0. So it's all mirrored along this line here. That's essentially what even symmetry means, right? So you can only do this with even numbers. You can't really do it with odd numbers, I think. Well, maybe you could, but I haven't figured out how yet. And then for the center stackup, we are going to create a no symmetry. Just to show you the difference. Okay, there we go. Okay, so in this case, there's no symmetry. It's going to go 0, 45, 0. And I'm going to press OK. All right, there we go. And then once you're done with that, notice that there's green tick above conventional stackup, which was one that I made earlier, and there's a little lightning bolt next to each of the edge stackup, center stackup. So so that just means it's not updated and propagated within the model. So what you want to do is go up here. There's another lightning bolt. Press that. It just updates the entire model for you. Okay. All right. So under element sets, remember that we created 2 name selections in mechanical model. One was the edges and one was the center panel. So this will come into useful later. And then if you create edge sets, so essentially just lines that they'll appear under edge sets. So if I created a line, it'll come there. But for now, we're not going to worry about that. Okay. So now ignore geometry. That's not necessary. And then rosettes. You want to create a rosette. So essentially what a rosette does is it defines the fiber direction that you'll be laying down. So you want to create, right-click rosette, create rosette, and just, it doesn't matter, like you can name your rosettes based on what you want. So for example, if you have a 90-degree fold, so for example, something like this, what you want to do is create one rosette for the bottom and one rosette for the vertical edge, because the fiber directions aren't the same and they don't tend to flow over each other. However, if you're making a continuous prepreg piece, we'll talk about this later, but there is a way to do that, and it involves edge sets. But we'll cover that next lesson, I believe. Yeah. Okay. So yeah, we're just gonna name this like flat panel rosette. I think too fancy. Okay, and then now under origin, it's gonna ask you where you want to put. So you can just select any random piece, any position here, and then it will create a rosette. And then now you want to zoom in and look at okay. So now you have your green pointing up. So green stands for fiber direction. If you can't remember, just go up here and then look at the thing. If you hover over the different color arrows, it will show fiber direction. So that's just how I remember. So green shows fiber direction, and you want blue to blue shows transverse direction. So you want your blue to point upwards, your green and red to be flat on the panel that you're doing. So how do you achieve this? You just essentially play around until you get. Nope. Okay. Oh. So I'm gonna put 0, 1, 0. Okay. Oh, I see why. Okay, there we go. Wait, no. Oh. Okay, I think that's fine. Okay, as in usually I'm just more concerned about the green direction, but it should be fine for now. Okay, so we're gonna press OK, and then we're gonna go over to. So I already have a rosette here, which is wrong. Okay, so there's the lining signs. I'm going to click update. Okay. All right. So under oriented selection set, you want to create. You just want to go to click on the head and then create oriented selection set. And then it'll come up with oriented selection set, and then you want to just name them after what oriented under what element set they're using. So in this case, I'm using center. So the element set that I'm going to be using. So I go under element sets, click in between the two brackets, and then click on center, and then orientation. I just click anywhere. So I'll just click anywhere on the oriented selection set that I'm choosing. And then one important thing is to notice which direction the this big arrow is pointing. So this essentially means that let's say I have a flat panel. If the arrow is pointing up this way, I'm going to build my plies this way, up, up, up. So, and then if I want it the other way, like let's say I want to build downwards, then I have to flip the arrow. So if I click flip, the arrow points downwards, then it means it's going to build this way instead. So I want it to flip upwards, so it's fine. Selection methods, leave it as that is, and then under rosettes, click between the brackets again, and then choose the rosette that you created earlier, which is flat panel rosette. Okay. Yeah. And then you want to just press OK. And then I'm going to edit this. So if you want to edit an oriented selection set, you can right click on it and then click properties, and then you can rename it. So in this case, I'm going to rename this oriented selection set that I created earlier. And oh yeah, so also if you just want one piece, so for example, for a flat panel, usually you just make it one ply. You're not going to split it up into different geometries. Then you don't need to come up with name selection set, and automatically ANSYS will create this thing called an all elements set, which you can just use to give everything a uniform one ply. That's only if you're using one piece of carbon fiber for each ply. Then you can do this. All right. So in this case, I'm going to get rid of this. And then I'm going to click on edge. And yeah, this is then for the rosette. Yeah, panel rosette. So in this case, I can see that it's okay. The purple pointing up, correct. So just remember that if you're building, you have to create that. If you're having like a multi-piece structure, like for example a seat, make sure that the direction that you're building up on all align to the same direction. Otherwise, you're going to have a weird thing where one half of it goes up and the other half goes down, and that's just going to create a weird point of weakness here. And when you create, and it's not going to be able to solve during the mechanical analysis later when you apply a load, because there's no overlapping carbon fiber weave. So once that's done, you want to update. Reference direction, alternate method used in oriented selection set edge. Okay, that's fine. Okay. And then under modeling groups, you want to right click modeling groups, create modeling group. So in this case, let's call this edge modeling group. And then under edge modeling group, right click it again. And then you want to create apply. So this is where you start laying down the stacks. So you don't have to worry about what ply this is, but you can just say edge one. And then oriented selection set, this is where you go and select the oriented selection set that you created earlier. So in this case, I'm selecting edge. And then I'm going to create my ply material. So under here, I created edge stack up, remember? So I'm going to choose edge stack up. So this will automatically lay down 6 plies for me. I don't have to create multiple plies, modeling plies here. And then ply angle 0 degrees, because that's pretty much exactly what you want. Number of layers 1, because you don't want to create like 2, 3 layers, and just press OK. All right. And then under modeling group 1, we're going to click on properties. So this is how you edit a modeling group. Click on properties. So let's say this is the center. Modeling group. Okay, all right. And then modeling ply 1, you want to click on that. We click on properties again and just say center 1. Okay. And then you want to click on center, and then conventional stack up. Ply material, you want to choose um, center stack up, and then press OK. So now it's gonna populate, and you should see. And I'm just gonna click. Oh no. Oh, okay, that's fine. All right. Gonna click update project. Okay, and then on your right, you should see nothing but green arrows at this point. And that's pretty much it on how you successfully laid up your virtually laid up your flat panel. Okay, so now I'm going to zoom out. So one thing that I want to show you, want you to notice is that right now I've clicked on. So if I click on no fiber direction, you just see a blue flat panel. Okay, so I'm going to zoom out, zooming out. So, okay. Okay. So this is essentially how it looks right now. Oh no. Okay. So so just to do a sanity check, what you want to do is look on the left, and there's, oh god. Okay. So just to do a sanity check, what you want to do is check on the left. So this essentially shows that there's a color scheme for the different thicknesses. So remember that we said 2 millimeters for each ply, and the edges have we put an even symmetry, and we input 3. So that means you should get a total of 6 plies on the edges. 6 plies times 2 millimeters equals 12 millimeters. So if I look on the edges, I have 12 millimeters worth of carbon fiber on the edges. And then same thing goes for the center. But in this case, we didn't do even symmetry. We just said no symmetry. So ANSYS did not mirror it along the center axis. So you just get what you put is what you get. So in this case, we got 3 plies times 2 millimeters, 6 millimeters. There's blue. You can see the center is blue. So pretty much what we expected to see. Now, another thing that you want to check is fiber direction. So when you go up here, you want to click on the neon green, and when you hover over it, it should show fiber direction. So if you click on it, it will. Come on. Okay. So what will happen is you can see that there's little lines that appear. So you want to just take a general look at it, make sure that all the lines are pointing in one uniform direction. It's okay if there's a few spots like here and here, but generally you just want an even parallel distribution of lines across the entire thing. That just shows that your fibers are laid correctly and how it's oriented. So what these lines essentially signify is your, if you look at your carbon fiber weave, you'll know, like if you remember, there's your carbon fiber weave tends to flow in one direction, right? There's like one direction that goes this way, and another direction that goes perpendicular to that. So when you're laying up, you always put it like that, right? So it's sort of like you lay the 0-degree direction along the flat panel, and then the 90-degree panel will go like perpendicular to that. So just imagine this is the carbon fiber thing that you're laying down on, right? So once you're done, and you think it's good to go, then you just have to close it. And click on Update Project. So now under setup, you'll notice that all of it is green arrows. Okay, yep. So once you're done with that, now this is where you sort of the analysis parts comes in. Up until now, you're just setting up the thing for analysis, but now you are going to analyze it. So we're done with the component system. So now we're going to go under analysis systems. Let's open this up. Under toolbox. So under toolbox, you want to go under static structural. So generally we do static structural. You can do dynamic structural if you want, but it's good to start off with a static structural analysis first, right? So I'm going to click and drag it, and okay, I'm going to click and drag it. I'm not going to connect to anything. And then now what I'm going to do is I'm going to click and drag setup. And drag it over to the model. So model of the static structural box that I just put in, okay? And then it's going to ask you transfer solid composite data, transfer shell composite data. So I'm going to select transfer shell composite data, okay? So in FEA analysis, there are generally two types of analysis that you can do. Like very broadly speaking, one is solid. So that means you have a three-dimensional element. So what that means is that you have X and Y along with Z. So your nodes can also, so remember what I talked about nodes, they can go in the X, they can, essentially your nodes connect each other along the entire structure, and that's what gives the, and essentially you're analyzing how the nodes react with respect to each other, and that's where you get your analysis from. So your nodes can travel in the X, Y, and Z direction, but if you also look, that's for solid. For shell, they only travel in the X and Y. So it only happens on the surface of the structure. We tend to use it's easier on the computer and faster to compute using shell with respect to carbon fiber, because carbon fiber is so thin in the Z direction with respect to the X and Y. So if you look at the seat, like the seat itself is humongous, but then if you look at the thickness of the seat, it's ridiculously, it's like negligible compared to the X and Y dimensions of the seat. So in this case, we can use a shell. So that's why also, if you remember, under the engineering data, when we input the values, we only cared about the X and Y values. We didn't care about the Z values. That's because we were going to do a shell analysis later on. So once you've done so that's essentially the rationale behind choosing a shell. So once you've done that, you want to click on model again, and it'll start mechanical. That's odd. Okay. Okay, so if you look at it, it sort of looks like, okay, I know what the issue is, but yeah. So when I was creating in SolidWorks, I created it in inch dimensions. And when I imported it, and then I started working in metric in ANSYS. So that's why the thickness looks so weird with respect to the, yeah, okay. So that's weird. Okay. Anyways, it's fine. Okay. All right. So yeah, so once you're here, essentially what you want to do is under structural. Okay. All right. I think I'm going to end here because we're running out of time. So next week we'll go over structural, and then after I'm done with that, so here's the plan for next week. So next week I'm going to go static structural, teach you guys how to set it up, analyze it, interpret the data, so it makes some sense, and then I'm going to give you like a simple assignment, like so essentially just analyze another flat panel, and come up with the recommended, the minimum number of plies that you need to achieve a certain factor of safety. All right. So I'll give you the assignment next week after I finish teaching you guys about static structural. All right. So is there any questions about anything that I've talked about so far today? Okay. Everyone's good? All right. I assume. Okay. I'm gonna.
Thanks, Abhi.
Okay. Sounds good. All right. So if you guys have any questions throughout next week, or if you want to play with ANSYS, you feel free to use the screen share. Like, and if you can get this the student edition of ANSYS to work on a laptop, go for it. The problem with that is I find that a lot of our laptops aren't really built to handle ANSYS because ANSYS is very intensive. So yeah, I would recommend using the screen share and getting used to using the remote desktop into the racing computers, especially because when you start doing the bigger FPA items, you can only use the racing desktop because yeah, that's a lot more. It has a lot more cores that you can use. So it's just better for computation. Yeah. So if you have any questions throughout the week, just feel free to drop me a chat, and then I'll see you guys again next week. All right? Sounds good? All right. Goodbye, guys.